So the question is my pursuit of a theory of FAI, friendly AI, similar to, say, Marcus Hutter's ICSI, which is intractable in practice but offers an interesting intuition pump, or do I intend on arriving at the actual blueprint? So definitely actual blueprint, but on the way to an actual blueprint, you probably have to, as an intermediate step, construct intractable theories that tell you what you're trying to do and enable you to understand what's going on when you're trying to do something. If you want a precise, practical AI, you don't get there by starting with an imprecise practical AI and going to a precise practical AI. You start with a precise impractical AI and then go to a precise practical AI. I probably should write that down somewhere else because it's extremely important. There's various people who will try to dispute it, and yet at the same time it also hopefully ought to be fairly obvious if you're not motivated to arrive at a particular answer there. You don't just run out and construct something imprecise because, yeah, sure, you'll get some experimental observations off of that, but what are your experimental observations telling you? And one can say along the lines of, well, I won't know that until I see it, and I suppose that has been known to happen a certain number of times in history. Just inventing the math has also happened a certain number of times in history. We already have a very large body of experimental observations of various forms of imprecise AIs, both the domain-specific types that we have now and the sort of imprecise AI constituted by human beings. And we already have a large body of experimental data, and eyeballing it, well, I'm not going to say it doesn't help. But on the other hand, we already have this data, and now there's the sort of math step in which we understand what exactly is going on. And then the further step of translating the math back into reality. It is the goal of the Singularity Institute to build a friendly AI. That's how the world gets saved. Someone has to do it. A lot of people tend to think that this is going to require, like a country's worth of computing power or something like that, but that's because the problem seems very difficult because they don't understand it, so they imagine throwing something at it that seems very large and powerful and gives this big impression of force, which might be a country-sized computing grid, or it might be a Manhattan Project's worth of computer scientists. But size matters not, as Yoda says. What matters is understanding. And if the understanding is widespread enough, then someone's just going to grab the understanding and use it to throw together the much simpler AI that does destroy the world, the one that's built to much lower standards. So the model of sort of, yes, you need the understanding. The understanding has to be concentrated in a group of people small enough that there is not one defector in the group who goes off and destroys the world, and then those people have to build an AI. That's if you condition on the fact that the world got saved and look backward in history, I expect that is what happened in the majority of cases where a world anything like this one gets saved. And working back from there, they will have needed a precise theory, because otherwise they're doomed. You can make mistakes and blow yourself up, even if you think you have a precise theory. But if you don't have a precise theory, you're completely doomed. Or if you don't even think you have a precise theory, you're completely doomed. And working back from there, you probably find that there were people who were spending a lot of time doing math based on the experimental results that other people had sort of blundered out into the dark and gathered, because it's a lot easier to blunder out into the dark. More people can do it. Lots more people have done it. It's the math part that's really difficult. So I expect that if you look further back in time, you see, a small group of people who had honed their ability to understand difficult things to a very high pitch, and then were working primarily on doing math and relying on either experimental data that other people gathered by accident, or doing experiments where they have a very clear idea why they're doing the experiment and what different results will tell them.